Section 4.4, trigonometric functions of any angle. The point 4, -3 is on the terminal side of x. Find all 6 trigonometric functions of x. So you'll prepare 4, -3. 4, -3 takes us into quadrant 4. To the right 4, down -3. Notice this is a Pythagorean triple, and this is where you'll start seeing these pop up over and over again. This is a 3, 4, 5 triangle. So now we need to find 6 functions. Sine, cosine, tangent, sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Cosecant is the reciprocal of sine. Secant, reciprocal of cosine. Cotangent, reciprocal of tangent. So once again, once you have the triangle, it's the same thing as what we've been doing over and over again. You should be getting pretty good at drawing these reference triangles and finding the 6 functions by this point. Given cosine theta is 3/5 and tangent is less than 0. So now we don't necessarily know where we are going to draw the reference triangle. This is where your all students take calculus is going to help you. Cosine is positive. We know before we start this that cosine is positive in 2 quadrants. All students take calculus means that cosine is positive here and here. Tangent of this same angle has to be less than 0, meaning that it's negative. All students take calculus. Tangent is positive in 1 and 3, negative in 2 and 4. So where is cosine positive and tangent negative? Right down here in quadrant 4. So you have to be careful of where you're going to draw your triangle, because now that is going to tell you whether you have a certain leg that is positive or negative. Cosine of this angle now is adjacent over hypotenuse. Pythagorean triple again, that side has to be -4. And now we want to find the sine and the cotangent of that angle. Sine opposite over hypotenuse is -4/5. Cotangent, tangent is opposite over adjacent, so this is going to be adjacent over opposite, -3/4. Find each reference angle by sketching a reference triangle. So working on picking out here what reference angles we would be working with. We're going to rotate 125 degrees. That takes us into quadrant 2 here. Now we need to figure out the reference angle, which we can call x. What does x have to be? Well, if I rotate all the way halfway around, that's 180. I didn't go that far. I only went 125. 180 minus 125 gives us a reference angle of 55 degrees. Letter B, 4.5 radians. 4.5 radians. And again, I know this is radian because there is no degree symbol. Well, if I rotate up here radian-wise, that's pi over 2. Plug into your calculator. Pi divided by 2 is about 1.57 radians. If I go here, that is pi radians, which we know is about 3.14. If I go down here, it's 3 pi over 2. Put that into your calculator. That's about 4.71 radians. Again, this was pi over 2. This was pi. This is 3 pi over 2. Well, 4.5 radians is between 3.14 and 4.71. So our reference triangle is going to be drawn right here in quadrant 3. There's our reference triangle. This represented a rotation of 4.5 radians. We need to figure out, again, what is that angle there? Well, to get to this edge, it was 4.5 radians. To get to here is 3.14, so take 4.5, subtract 3.14, and that means our reference angle x is going to be 1.358 radians. Last one, C. Negative 135 degrees. Negative means I'm rotating this way. End up in quadrant 3 here. We're looking for the reference angle, again, x. Well, I know that I would have went 180 to get all the way up there. I'm not going all the way up there. I'm only going negative 135, so subtract 180, and we get a reference angle of 45 degrees.